Today we're going to be doing 2.6 algebraic proof. And just bear with me, I'm going to be at my computer and going up to the board, so the sound might vary. I'm going to try to speak loudly when I'm at the board to help you. First of all, this following table is going to summarize some properties of real numbers that you would have studied in algebra. And these are some properties that you're going to need to memorize. So we're going to be using these when we're doing some algebraic proofs. So the addition property is if you're adding the same thing to both sides of the equal sign. Subtraction property of equalities when you're subtracting the same thing on both sides of the equal sign. Same idea, multiplication and division, you're multiplying by the same thing or dividing by the same thing. The reflexive property is when you're equal to yourself or equal to itself. Symmetric property just allows you to flip it, so whatever's on one side of the equal sign can go to the other. Transitive property, similar to substitution in that if you have two things that are equal to the same thing, you can cancel out what's repeated, which is that B in this case, and just say that A is equal to C. Substitution allows you to put A in. If A is equal to B, you can replace your B with A every single time. And then distributive property would be obviously when you are multiplying through your parentheses. So an algebraic proof is a proof that is made up of a series of algebraic statements. So I want you to see the proof in your book so you can see what this looks like. So if you were asked to prove this equation, -5 times the quantity x plus 4 equals 70, and then that x equals -18, you're going to write a justification for each step. So here's what would happen. You'd start with your given, like you did with your paragraph proofs. You would write given. And then you would do the equation. So I would be multiplying by -5 through, which is distributive. That would be my reason. And I would probably skip this step right here. I would just probably write this as -5x minus 20 equals 70 and call that distributive property. That would be fine. Then we're going to add 20 to both sides to solve. That would be the addition property. And then -5x equals 90. That's your substitution. Another thing you could write instead of substitution, I would be okay with if you wrote simplify there. And then we're dividing by -5. So there's your division property. And then x equals -18. Again, you could say substitution there, or I would be, whoops, sorry about that. Or I would be okay with simplify because that's the same idea that you're simplifying. So we're going to try, before we do a full proof, we're just going to state the property that justifies each statement. So I am going to go to the board, so I'm hoping you can still hear me. So 1A is 4 plus -5 equals -1, then x plus 4 plus -5 equals x minus 1. So you should notice that this is what's added to both sides. So this would be the addition property of equality. Okay, 1B is y equals 5, or 5 equals y, and y equals 5. Where you can flip these. This is the symmetric property. And the last one we're going to do here is we're going to do a proof here, where we're going to solve it and write our justification. So we're going to start with our given. And then the first thing we would do would be to add 13 to both sides. That's our addition property. And then we would simplify that and say 2x equals 8, and that is your substitution. Or we can write simplify. And then I'm going to skip a step here. We're just going to say what x equals, which is, we got to that from the division property of equality. Okay, now we're going to talk about two-count proofs. So a two-column proof contains statement and reason. And those are organized into two columns. Okay, so we're going to look at this two-column proof, and I'm going to show you how this is going to go. Before we do that, I want to draw your attention to one out of the book for you to see. Well, maybe that's later. Okay, so I'm just going to show you what this one's going to look like. We're going to do a two-column proof with this. It's still algebraic, but I just want you to see how it's set up. So again, you always start with your given. That's going to be our first statement. And the reason is just given. And you are going to number these. And then I would multiply by 9/5 on both sides. So this would be the multiplication property. And then that would give me 9/5 C. And then those would cancel out here. They would cancel. And left with F minus 32. And that could be your substitution or simplify. And then I need to add 32 to both sides. That's addition. And I'm going to simplify that. And then I'm going to rewrite it with F on the left. And it has to look exactly like what they're asking us to prove. And that's symmetric. Okay? So now we're going to do this again, right? Two-column proof. So you set up your statements and reason. And you always start with your given. And then we're going to start solving. So the first thing I would do is add 8. This is where if you want to skip a step, you can. And then I would just say addition. Then I'm going to multiply by 2. That's multiplication, property of equality. Then I'm going to subtract 1. That's your subtraction property of equality. And to get x equals 3, I divide. And there's your division property of equality. And so I've proved the conjecture that they've asked me to, that x equals 3. So you always start with your given, get your statement justified on your reason side, and then you have your proof. three properties you need to know that you can use in geometry, not just with real numbers. So segments in angles can also hold these properties. So segments can be reflexive and symmetric and transitive, along with angles. The important thing that you should note here is that all of these that we're talking about, these segments, these are their measures. You don't see any segment signs above these. These are their measures. So we're talking about the measures of the segments because those measures represent real numbers. Back. Okay, so reflexive, again, it's equal to itself. Symmetric is just that I can switch it left to right on the equal sign. And then transitive, again, if you have two things equal to the same thing, you can cancel out that CD, which is the same. Same idea with angles. Again, notice we're talking about measures here. That's why we have that M in front of them. So the reflexive property will hold true. The symmetric property holds true, along with the transitive. Again, only if we're saying they're measures, not if you see congruent symbols. That's not the same. So I want you to see this geometric proof here, and you guys can obviously look at this in your book as well. I want to show you an example of a geometric proof. So here are the things that they're giving us. If angle FGJ is congruent to JGK and angle JGK is congruent to KGH, then x equals 6. So they're also giving us these measures here. If you notice, this 6x minus 7 and this 8x minus 5. Okay, so the question is prove that x equals 6. All right, so we do our statements and our reason. So you always start with your given, and your given is what's either written for you, which is these two things up here that are written, but it's also whatever is given to you in your picture. So they've given us those measures, so we also write that. And you just write all of your givens in the one statement, and then you write given. Okay, so the second thing would be that the measures of the angles are equal. So if angles are congruent, you know that their measures are equal, and you would always say that. And so you can say here, if angles are congruent, their measures are equal, or you can just say the definition of congruent angles. And then what you should notice here is this was repeated, right? That measure of angle JGK. So they're just replacing it. They're taking it away and replacing it with just these two, and that's that transitive property we were talking about. And then they're substituting in the measures of those angles. 6x plus 7 equals 8x minus 5. And now you're going to see we're solving. So we're adding 5 to both sides. So now we have 6x plus 12 equals 8x, and that's substitution. And then we're subtracting 6x on both sides. There's your subtraction, which now they're going to substitute. That gets us down to 12 equals 2x. And then we're going to divide by 2 on both sides. And that gives us 6 equals x using that substitution. Or again, that's the same as simplify. And then we have to always make sure we finish it where our proof, our final statement matches theirs. So if they have x equals 6, you have to have that final statement on yours. And then you're going to use the symmetric property to justify that. Okay, so we're going to practice 2 of these together. So we're going to write a 2-column proof to verify each conjecture. So we're going to start and do 3A. So we're just going to set up 2 columns in here. So let's go ahead and do that. And head back up to the front. Hopefully you can hear me. All right, we're going to always start with our given. Angle A, congruent with angle B. And the measure angle A equals 37. Okay, now, just like we talked about earlier, if angles are congruent, then we know their measures are equal. We can say measure angle A equals the measure angle B. And I'm just going to say if angles are congruent, their measures are equal. And then, instead of writing measure angle A, you can plug in 37 there. And that would be substitution. Then we can rewrite it, split it. And we can flip it by the symmetric property. Okay, let's try another one. We're going to start with our given. Our other given is what the measures of those segments are, so we need to write that down. So the measure of CD, no segment sign, is 3y minus 9. And the measure of EF is 15. Those are given. And then again, if segments are congruent, we know their measures are equal. And once I say that their measures are equal, then I can plug in their measures. And that's with substitution. And now we can start solving. So I got that by doing addition. And I got that by doing division. And that's what it's asking for. It's asking us to prove y equals 8. And we did that, so we're done. And here is your homework assignment for tonight. Page 139, you're going to do 9 through 19, and then 24 and 25. 24 and 25 are going to be 2-column proofs for you to do on your own.